cross section area. So, we can say that on that basis this D is nothing but whatever with the initial area is there minus final area with respect to the initial area, or in terms of diameter we can say that this one is a di square diameter at initial minus diameter at final upon di square, or this may be written as 1 minus d final minus d initial whole square. And the another strain that is we are discussing here the true strain. One is engineering strain, another one is a true strain, and that is denoted by the epsilon. According to that, this one is defined as logarithmic ratio of the A initial minus area at the final one. Or here if we interrelate the above one, so this would be equal to our log of 1 upon 1 minus d. So, the AI is there, initial and final area is there, and its ratio log of that is taken as a true strain. So, till now what we have discussed, we have discussed about the component of the drawing processes, in which bell shape is there, conical is there, straight edge is there, and after that again the bell shape is there for the exit one. And after that we have discussed about the reduction factor, that is given by capital D, and finally we have come on the true strain. Engineering strain is there and true strain is there, and true strain is given by the log of 1 upon 1 minus d. So, now we will discuss about the elemental strip. So, whatever the earlier we have taken here, the small elemental strip is there during drawing operation. So, the force, the pressure P is acting on that one, total pressure is there. Regarding the force, mu P is a frictional force acting opposite to the material flow. Here we have taken the length as a dx. Regarding that, whatever be the sigma x is there, the force that is acting on the right hand side of the strip, that is a sigma x, and certainly on the other side, on the left hand side of the strip, that is sigma x plus d sigma x. So, here it is a sigma x plus d sigma x. The radius we have taken as a r for the strip. On the left hand side, where it is a slightly bigger one, here we are considering as a r plus dr as a radius. Of course, we have considered our semi-cone angle, that is a alpha. The radius is taken in the y direction only. Similarly, all the processes would be there, all the forces acting on the below direction, below one here as a mu p, and the force whatever with the p is there, and x already you can observe it this. If for the same, this one is a, the first figure whatever you are observing it here, this one is a round shape. So, it has a circular shape, and our strip you can say it is a something like this, a small strip is there, and here the second segment we are taking a small segment of this one, so this one is a small segment which we are going to consider here in the second figure. In that, the force that P is acting here in the first figure. So, from the top, if you will observe here, if it is a vertical line, so this angle would be our alpha, and another direction that is horizontal, if we are taking it as a horizontal one. So, this would be a against our pressure, the drawing force. So, here the P cos alpha, it is alpha is here. So, if we are considering it here, this one is also alpha. So, here we have a alpha and whatever with the pressure is there. So, that from the top, if we are observing it here, we have a P cos alpha minus mu P sin alpha would be acting from the top of this small element here, and from the below you can say that this is a alpha r, sigma r you can see here, this one is a sigma r. So, this one is a nothing you can say as a, this side it is a sigma r, or this one is a, and here it is a sigma theta. The clarity is here that this one is a sigma theta. So, here we have taken the strip. This strip is nothing but, if the side view would be there, means we will observe it would be a circular one. On the circular, we have taken whatever be the d theta is there. This angle is d theta. For this one, here in segment 2 or figure 2, the detail is shown to us. So, P cos alpha minus mu P sin alpha is there, means whatever the mu P is there, P from the top, the two component of the P is there, P cos alpha is from the top. Another one, if mu P is here, its direction is upward direction. So, minus mu P sin alpha is there. So, this one is a total pressure that we can consider from the top. Similarly, here sigma r is downward direction from the inner one. At the edge here we have a sigma theta. And the radius is, along the radius, the small strip, that is a del r. So, we are going to discuss, we are going to analyze the forces on this segment. Now, we have to consider whatever the plate was there. In a plate, we have a small strip is there, and this strip, here we have a strip, this is symmetrical about the central line, sigma x was acting here in this direction, and in another direction you can say that this is a sigma x plus d sigma x. So, this one is acting, and here whatever be the radius was there, as you can observe it here, the radius is nothing but this is r plus del r plus dr, and here we have a radius r from here to here. So, considering the equilibrium of the element, considering the equilibrium of the element we have taken, in x direction, this one is a, we can say that sigma x plus d sigma x, whatever be the area, that is a pi r square. So, here we have a pi, and at the place of r it is radius, that the radius r plus dr is there. So, whole square of this one. This one is in the x direction. In another direction you can say that this one is a sigma x into this pi r square, and if we consider about the forces, so from the top we have a pressure P is there, and the frictional force, that is mu p, is here. So, if we are considering the frictional force, then we have to, it is along the x direction. So, the mu p into the 2 pi r, that is a circumference, and for the small area, if this one is a dx, you can think about this one. If we are, the dx is here, then whatever with the total length is there, this total length would be dx upon cos alpha. So, here we can write it as a dx upon cos alpha into cos alpha, because its component along the x direction. The another remaining part is due to the pressure. So, this is a P into the 2 pi r, it is acting on the same area. So, dx upon cos alpha into sin alpha. So, this one is an important expression, and another we have to keep it here in as a substitution, that the tan alpha is equal to r plus dr minus r whole upon, we can say, the total length, this is dx, or it may be written as dr upon dx. So, here you can take this one as so the distance, this one is nothing plus the above one r plus dr minus r is there. So, this one is, you can say, r plus dr minus r, and the distance here is dx. So, finally, we have a tan alpha is equal to dr by dx, and after that just putting this value, means here in equation 1 is there. So, for the equation 1, if we multiply each term and we neglect the higher order term, in that case the final expression would be, that is the final expression that is given by r, that is given by the r. So, the final expression that is given by our r dx, sigma x plus d sigma x is there, then pi term is there, r plus dr is there.